Hey, we're going to be looking at this curve here, and the idea is we're going to be finding the derivative using the definition of the derivative, and we're going to find the slope of this tangent line here at the point. This is the x value is 2, and I'm not exactly sure what the y value is. I guess it's 2 also, so it's what it looks to me like. Maybe. I don't know. We'll look at the function here in just a second. But the final part to this is we want to find the slope of the tangent line. But first off, we want to find the derivative, and that would give us the slope at any given point on the curve here of the tangent line. So we want to remember here what the definition of the derivative is. I've got this m tangent, that's the slope of the tangent line, and it's usually denoted as f prime of x. And we're going to be taking the limit as delta x approaches 0, and this is what we're going to be using here, and this is like finding the slope of a line. And you got your difference in y's and your difference in x's here. This is what we're going to be using. So our function happens to be f of x is equal to x squared over 2. Now we're wanting to know what that y value was. If I plug 2 in here, I get 4, 2 into 4 is 2, so it was 2, 2. The point's 2, 2 is the point on the graph that we're interested in. But anyway, so here's our function. We're going to be taking x plus delta x and plugging it in for x here, as you can see. And it's over 2 minus f of x, and this is our f of x, and it's all over delta x. So now what we want to do here is simplify this down as much as we can. We've got x plus delta x squared. We're going to need to FOIL this stuff out. We got x times x is x squared, then you have x times delta x and a delta x times x. There's 2 of those terms, that's the reason there's a 2 here. And then delta x times delta x is delta x squared minus x squared. And we have a common denominator, so we can join the numerators together, get this all into one single fraction, and I do that here. We want to let's see, we want to drop this down. So this 2 here gets dropped down into the denominator. And what am I going to be doing next here? It looks like there's no difference in this one and this one here. So, okay, it looks like I've repeated these, but that's okay. So the x squared here and negative x squared, those are going to cancel out, and I show that here. They've now disappeared. And then we have delta x goes into this delta x, so it has disappeared, and we have a delta x here and 2 delta x's up here, and that leaves us with 1 delta x. And now we've got it down as simplified it as far as we can. And now we're going to take the limit by doing direct substitution, and that means plugging 0 directly in for delta x, which I have done here. And now we are doing nothing more than simplifying this down. So what I've done here is I've just rewritten this down here, and you notice that I've got equal signs here, so we don't want to leave off the equal signs. It's very important that we don't leave off the equal signs, because all of these are equal to each other. And now we've gotten down to f prime of x, which is equal to x. So after this is simplified down, we're just left with an x. And then we wanted to find the slope of that tangent line, so remember at x equals 2, and we can do that now. We just plug 2 in, and the slope is 2. So you can find the slope of the tangent line at any given point on the graph by just plugging in the number here and whatever that number out is.